Hi Gibberlites, welcome back. This is Mr. Lin again. Now in the previous video, we have managed to show the development of the keytag coin holder in three areas. First, the position of coins in the coin holder. Number two, the user's grip, left hand and right hand on the coin holder. And number three, how it acts as a key tag by looking at the position of the key ring. Today, we are going to move on to the next part of the development, and this is a critical part which involves the exact dimensioning of the design. Now, before we go into demonstrating the exact dimensions, how they are obtained, I would like to show basically what dimensions are really all about and how can we dimension simple shapes, squares, rectangles, circles and ellipses. That would help us to form out our shape to the exact dimensions. Now, whenever we talk about dimensions in D&T, our dimensions are always in millimeters. And whenever we talk about dimensions, we will talk about two values, the horizontal length and the vertical length. And this is very similar to Cartesian coordinates, or how we sketch graphs, x value being the horizontal value and y value being the vertical value. So, take for example this particular square. This square has got a horizontal value and a vertical value taken about a reference point, and this reference point can be at this bottom left corner of the square. So the horizontal value in this case is 10 cm or 100 mm, so we will indicate 100 over here, and since it's a square, this will be 100 as well. So that's how we dimension a square. Now if we have a small rectangle within that square, and we might need to reference it against this reference point. Say for example, I have a rectangle there, and I would like to know the dimension of this rectangle. So just the dimension itself, that's pretty straightforward. Okay, in this case, this is about 5, okay, or 50 mm from the top. Always remember to sketch. That's 50, and this is approximately 25, about 25 from this edge, right? However, this only tells me the x and the y value of this particular rectangle. If I need these values from a reference point, I would need to have the distance from this reference point vertically as well as horizontally. So say for example, I want to find the lowest point of this rectangle from the reference point, then I would have to continue to project over here, and since this is 100, this will be 75. At the same time, how far is this lowest point of rectangle from the reference point? Okay, we can indicate at this location, okay, from the reference point, and since that was 50, this must also be 50. Sorry. So with that, this entire rectangle has been positioned with respect to the reference point. So this is what we do in dimensioning. We tell people the length of the object and the location of this object with respect to a reference point. Now this concept is very important. It's similar to concepts of velocity and forces, which many of you will learn in future. Now if I were to dimension a shape like this, okay, for example a parallelogram. Let me shift the camera a little bit. Right, now we will need to learn sometimes a few other things. For example, other than the reference point, we can talk about a reference edge. Now this is a parallelogram or a trapezium, similar to a trapezium, and basically to locate this parallelogram, first we have the reference point, then we need to give the dimensions to this particular parallelogram. Now, this parallelogram is actually a 100 mm square slanted to a side. So what I need to do is to decide how far is this point from this reference edge, okay, and then how high is this from this reference edge. That will give me the location of this point. So the distance from here to the edge, okay, is dimensioned in this way, and this is given by the value of 40. Alright, now I would like to know what is this height. This height is approximately 92 mm. So I can do it here. Normally I would like to put my dimensions outside, okay, but in this case I'm just showing it here. So that's 92 mm. So that tells me that this point A is perhaps 40 mm to the right of X, 92 mm over the top of X. That's point A. The next thing we would have to tell people reading this drawing is the length, and this entire length we would have to dimension as well. And when we dimension, we would try to position this just in front of that length, and this is 100 mm. So in terms of dimensioning, we need to tell people the length of this edge of the parallelogram, and we have to tell the position of this point from a reference point. So when we do that similarly to other points, we will actually determine and define the exact shape of this parallelogram. So let me go ahead and show you how we should do that. Okay, I will darken this a little bit further so I can differentiate them from the dimension lines. So you will notice that dimension lines, I will always have projection lines, the dimension line itself with the arrows and the numbers above the dimension line. So since I mentioned that this is actually a 100 by 100, I'm not going to dimension that. I'm just going to locate the various points. So this, let's call it point B. Alright, so how far is point B from reference point X? To do that, we can project upwards, and let this project upwards some more, and let's have a horizontal line. That's the dimension line, and this distance is measured to be 140 mm. Okay, so horizontally B is 140 mm to the right of point X. Vertically, okay, vertically, let's do that. Do the projection, draw the arrows, and this will also be the same, 92, right? 92. So we confirm that A and B are horizontal. Alright, and we have just located B. Now, how do we locate C then? C is very simply this horizontal distance, and since this was a parallelogram, and we said that this was actually a similar in dimension, so we are very sure that therefore point C is 100 mm to the right of X. So you notice that we have taken our dimensions from the two reference edges and the reference point X. So this is how we give dimension to an object like this. Now what happens when we come to circles? Now circles, very similarly, we would need to give the dimension of the circle. So how do we define the dimension of a circle? Usually that is given by the diameter. And the second thing we need to do is to locate the center point of the circle. This allows anyone to find the exact location, and if we were to duplicate this drawing somewhere else, we will know how to duplicate it with respect to a reference point. So let's say reference point X. First, let me define the location of the center point. And just like the previous exercise, basically we will be looking at the horizontal as well as the vertical distance from the reference edges. So horizontally, the center point is 50 mm from the vertical reference edge. So that's horizontal distance. How about the vertical distance? Okay, the vertical distance, let's define there. And the vertical distance is given by 50 mm from the horizontal reference edge. Once we have located the center of the circle, then what we have to do is to tell everyone what's the diameter. And to tell the diameter, basically you could draw a diagonal line through the center of the circle, and basically from the 2 points you can show this way. How we normally show the dimension of a circle is by drawing an arrow. Now we are giving the diameter of the circle, so this is the diameter symbol, and I've measured it as 76 mm. Alright, so if I were to show again, let's say this position, okay, so a sharp protrusion there, draw an arrow, and diameter 76. Now sometimes we want to tell others the radius instead of the diameter, so that's perfectly fine. If you want to use the word radius instead of diameter, draw an arrow, draw a horizontal line, and its radius 38. Alright, so remember, always point towards the center of the circle. That will tell people the dimensions. And when it comes to ellipses, it is a little bit more tricky. Alright, for ellipses, what we really need to do, just like in circles, we need to define the center of the ellipses. Alright, center of the ellipses. I'm going to demonstrate how to sketch this later. So we need to define the center of the ellipses with respect to, again, a reference point. So let's say point X. The second thing we will have to define for an ellipse is how long is it along its major axis or long axis, as well as the length on the minor axis or the short axis. Okay, so let me give one example here. So this ellipse, first we need to define the center, and let me just quickly show you where the center is. So with respect to the reference edges, okay, so this is approximately, this is 20 and this is 40. So that defines the center of this particular ellipse. Now, and we will need to define now the length, okay, of both the along the short axis as well as along the long axis. So this is how it is done. This length is also 20, remember right above the line, and this is 50. So an ellipse is defined by the center of the circle, the length along the long axis, or the length along the short axis. Let me show this. Now this ellipse is approximately, project that out. Okay, to locate the center, this is about 50, and this I'm kind of short of space, so let's do it across the other side. This is approximately 90. Right, so that defines the center of this ellipse. And oh, I'm so sorry, did I miss that? So 50 and 90. And this half from this edge pitch of the ellipse, that's 40. So in other words, this length along the long axis is 80. And let's do this on this side. And we have 40. So this is the length of the short axis along the short axis. Now, I'm going to demonstrate how to sketch the ellipse. So supposedly I have defined the length of both the short axis and the long axis. I've located where the center is. How do we sketch? Now, I would need us to remember to always sketch this rectangle. With this rectangle, it gives us a good frame. Now, basically, how did I form this curve? Okay, so when it comes to the vertices of the ellipse, now imagine that the ellipse is always going to be tangent. Okay, so it's always going to be tangent to that point. So similarly here, it's going to be tangent to that point. So I'm not teaching you to use compasses and all that, because that will become very, very technical. So try to sketch lightly. Okay, so from the tangent, curve up and try to form the shape. It's okay to make mistakes, and if you think it's too sharp, just make that correction. Remember, you sketch lightly, so it's always okay to make this correction. Now, this is slightly different from the usual practice of us going over and over again, because at this point we are trying to get a more accurate picture with measurements, so we would need to be able to be more precise with the shape. So I'm just going over to make the shape a little bit clearer. Once you have the shape out, you can be more sure with your outline. Alright, so it's okay, just have that shape out. You can still modify if you don't feel that that's very perfect. Okay, so this is how we will draw an ellipse when it comes to the stage where we are getting the precise dimensions. The next part, I will be showing you how my keytag coin holder is going to be formed up by ellipses and circles. In the previous segment of my videos, I have arrived at two designs in terms of how users can hold the product. So one design is the user's hands are outside the product and the user's hand inside the product. Okay, and after this, I looked into how key rings can be attached to this product. So supposedly out of the two, I've decided that I'm going to go with this particular design. If you do that, please write your reasons. So I am going to show, for example, I'm going to choose this design. I have decided to go with this design as it is structurally stronger, meaning it doesn't break easily, alright, as compared to this particular design. Now with this design, let me just remind all of us that this is just a base shape. Now we would need to eventually get the exact dimensions for this shape so that we can duplicate the shape into each of the 3 layers. Remember, we have 3 pieces of acrylic, and to duplicate this shape on each of the 3 layers, we need the exact dimensions. So what I did was I traced this shape roughly from the last design in the development 3, and I'm going to use some ways, and I'm suggesting to all of you that if you can also do this. I'm going to use like a bottle cap, and this bottle cap will help me define more accurately the locations for the coin positions. Okay, so that's what I'm going to do, and once I do that, I can actually determine the location of the center of the circle and define the size of each of these positions. Similarly, I'm going to do that for the ellipse. Okay, even for this small ellipse, I'm going to try and do that as well. Okay, once we have that, we have the exact dimension of all these shapes and the exact location, we will be able to duplicate this very easily. You remember that in our previous projects, what we did was once we had the shape, okay, we will duplicate the shape so that we can cut out from paper one set of that shape. And that's exactly what we're going to do with this exercise. Alright, I've now enlarged this shape so that it's easier for us to see. I'm going to use this bottle cap. This bottle cap is 31 mm in diameter. Okay, 31 mm, let's bear that in mind. And I'm going to use different colors to represent each of the circles that I sketch and the dimensions of each of these circles, so that it is easier for us to identify the dimensions of the circles. So I'm going to start here. Alright, so that's the first circle, and being 3.1 mm, that's gonna be, I'm gonna place the ruler somewhere near the center and to check that it is about 3.1 mm, and with that I can determine where the center is. Right, so this is where the center of that circle is, and I'm going to get from the reference edges the dimensions of the center point of that circle, okay, with reference to the reference edges. Okay, so that's the horizontal and the vertical dimensions. Okay, and let's do the measurement. This is about 38, and this is about 16. Okay, right, let's do the second circle. So somewhere there, sketch the circle. Like I said, the different colors will allow us to actually identify the dimensions for the correct circles. Otherwise it can be quite confusing with so many lines involved. So that's the center, and from the edge, okay, and it's around there. Okay, so that's the horizontal dimension. This is about 40, and this vertical dimension, which we are going to project across here. We're going to assume that this, to make it simpler, we're going to assume that this circle is going to be centralized there as well, and this shall be 16. Once again, let's use a different color. Let me place this a bit further away, and this should give us a good location. So this is where approximately the center is, and just make sure that that's the center as well. Okay, and now I want to dimension this from this side. Okay, I've already ensured that the square is perfectly squared, so it should be clear. Let me dimension that a bit higher so that you can see. Yes, and this will be about 28. Alright, and yes, I mentioned earlier, this shall be 16. Okay, let's save some work. The next circle up here. Okay, let's leave its location somewhere there. Okay, so we go around and sketch that circle. Okay, that's there. Find where the center is, approximately there, center, and this with reference to the bottom. Okay, so let's put the arrows there. Alright, so we've gotten all these circles with respect to the reference edges. Okay, and each of these circles, just bear in mind, it's 3.1 cm, which is 31 mm in diameter. That makes each half approximately 15.5 radius. Okay, so just bear that in mind. Now let's look at the ellipses. Now the ellipses, what we have to do based on this ellipse, let's look for the longest portion. So somewhere here perhaps. Okay, that's the major axis or the long axis, and if I were to base on this maximum length, this is about a 6.4, which means a 3.2. Okay, that's where the center point is, perpendicular to this. Let's see. Okay, let's take this as Okay, so this is 32 and 32 and 14 and 14 on each side. Now, this is the rough shape of the ellipse. I am just going to focus on the parts that are going to be the most important, and that's the exposed portion. Okay, so somewhere here. Okay, the rest of the ellipse I don't really need. Right, so that's the shape. Now for these smaller ellipses, okay, similarly, something like this, center, short axis. Now ideally, I would want these two centers to be almost at the same height, because that represents the left and the right of the ear. And so, okay, let me locate the center of this. This is at approximately 7, right? And the location of this from the edge. Okay, let's do 1 and excuse me, 1 more. Oh, I'm sorry. So this is about 80, and this is about 38. Now for these two ellipses, I'm just going to take the exterior shape somewhere around there, not very critical to measure that size. I realized I've forgotten to find the location of this ellipse, so that's critical. I am going to have to do it this way, extend that out. Alright, based on this, okay, I'm going to sketch this line. Okay, you can see. So this is that position, and it's about 66. Of course, you can also take reference from the top edge. I should have done that, maybe it's a bit easier to see. And then the location of the center of this ellipse. Okay, so I think I shall do it here, because I don't have much space. It's not ideal, but I just need to show where the center is. So this is about 20. Okay, so with that, I have gotten the position of every ellipse, every circle, by determining the centers and the size. Okay, for the smaller ellipses, not so bad. Okay, I think you can just give that a quick estimation. The bigger ones, you need to be very, very sure. So now I'm going to just do an outline over this whole thing. You can start from anywhere, so I want to start from the ears. So hopefully we can see that in the camera. So for me, I always just close up, okay, between the two shapes, and just follow this as closely as possible. Then when it comes to this kind of positions, just do a gradual curve, tangent to the next circle or the next shape, gradual. Now remember, this will form the natural positions where the grips are. Okay, let me shift that up, and there we go. Okay, so we are going to use this as more or less the final shape. And remember, we will have to try and duplicate this shape once more, and on that piece we're going to cut out, right? So this is the shape and the size determined.